Welcome to John Newton online class. In this video, I want to solve this particular question, which is wave. Now let's look at the question. The topic is a topic in physics. A plane progressive wave is represented by the equation y equals 2 sine bracket open 300 pi t minus 0.5 x bracket close, where the symbols have their usual meanings. Now we are expecting to find I, the frequency, I, the wavelength of the wave. Now let's proceed into the solution. But first of all, we should record that a progressive wave is a wave that transfers energy as it travels away from the source. Then, of which we have longitudinal and transverse waves, and that's for a progressive wave. But let's look at this question. Now, from progressive wave equation, we have that solution. From progressive wave equation, we have that y equals a sine bracket open 2 pi x over lambda minus omega t. This is our standard progressive wave equation. But recall that our omega equals 2 pi f. That's omega. Then when we substitute in this equation now, it will now give us that y equals a sine bracket open 2 pi x over lambda minus, when we substitute 2 pi f for omega, minus 2 pi f t bracket close. That's our standard equation. But from the given equation now, in the question says we have in the equation that y, the given equation here, equals 2 sine bracket open 300 pi t minus 0.5 x. This is what is given to us. Now we have two equations here, the standard equation and the given equation. Then we compare these two equations for us to find the frequency and the wavelength of the wave. Now, comparing this equation now, for question I, for the frequency, which is f, we now work. Now, comparing these two equations, we have this equation versus this equation. And the one with this pi ft versus the one with pi t. Now, equate them, you now have that 2 pi ft equals 300 pi t. That is comparing this equation, the standard equation versus the given equation. Now, from this place, we now have that we now make f subject of the formula. We have that f equals 300 pi t all over, this is 300 all over 2 pi t. Then you can see that pi t kills pi t here. Then we now have that we are left with 300 over 2. 300 divided by 2 will give us 150 hertz. So the frequency is 150 hertz. That one settled. Now let's look at the second question, the wavelength of the wave, which is lambda. For the wavelength, which is what? Lambda, the symbol lambda for the wavelength. Then we also compare the other equation, compare the other equation that involves wavelength, which is 0.5x and 2 pi x over lambda. Please do not be confused by this negative sign here or the arrangement in the bracket. It just symbolizes the direction of the wave. Okay, we now have that. Comparing it, we have that 2 pi x over lambda equals, compare here, 0.5x. Now, we now have this From here, we cross multiply, make this over 1, giving us 1 times the half, lambda times the half 0.5 x lambda equals 2 pi x. Then we divide both sides by coefficient of lambda. Lambda equals 2 pi x over 0.5 x. You can now see x cancel x here, leaving us with 2 pi over 0.5. Then that will be 2 pi over 0.5. 0.5 is 1 over 2 over 1 over 2. 2 pi over 1 over 2. Then which gives you 2 pi over 1 times 2 over 1. That's it. You invert it. Therefore, our lambda equals 2 times 2 is 4. 4 equals 4 pi. Our lambda is 4 pi. 4 pi meter. Or, given that if pi is 3.142, or lambda equals 4 times 3.142, which will now give you 4 times 2, you have 8. 4 times 4, we have 16. You write 6, carry 1. 4 times 1, you have 4 plus 1, 5. Then 4 times 3, you have 12. Put your decimal point here. When you approximate to 3 significant figures, it will give you 12 point. This is round up number. Put it here. It becomes what? 6 meters. That is when you substitute the value of pi. So our frequency is 150 Hz, and our wavelength lambda is 4 pi meter, or 12.6 meter. I hope you enjoyed this particular lesson. On wave. Thank you so much. Please subscribe to my YouTube channel.